All right, hello again. So today we're going to talk about just kind of a review of parent functions. So I just want to run through a quick list of what all we are going to be talking about and things you should know from Algebra 2, honestly. So this is going to be just kind of a quick run through of the parent functions. If you want to make this on your own set of notes, good idea to have a table. So we're going to talk about the function name, the equation, a rough sketch of the graph, and then the domain rule, which we'll talk more about domain and range the next couple of days. So the first one, I'm going to kind of go in kind of an order from simplest to a little more complicated, and kind of more or less the order that you did them in Algebra 2 last year. So the first one is probably the most boring of the bunch. It's a constant function, and it's just y equals c. So where c is just some number, it could be positive, negative, whatever. And of course, that's just going to be a horizontal line. So this is your xy axis. The graph itself is anywhere, like I say, pick a number, and that c is just going to be that horizontal line at wherever that c number is. Okay. Domain, obviously, x can be all real numbers. So negative infinity to infinity. Okay, again, not very exciting. Next one, did a lot of this in Algebra 1, is the linear function. Standard form of that is just y equals x. That's kind of the parent function. So again, this is also a line, but the parent function y equals x goes through the origin and has that slope of 1. And again, the domain is all real numbers. Next one we're going to talk about is the absolute value function. And that looks like the equation is those two vertical bars, if you remember that. And if you remember the equation of this, the graph of this looks like a V, where the vertex, the point of the V, is also at the origin. And again, the domain of this is also all real numbers. I guess I should also put the range of these things, although we're not as concerned with the range, but I'll go and come up here and add in the range also. The range, so let's go back to the constant real quick. So the range is just whatever that C value is, and that's all it is, because it doesn't go up or down at all. The range of the linear function is also all real numbers. And now we're back at the absolute value function, so now the domain is again all real numbers. That's going to be a recurring theme. Won't be all of them, but it's going to be a lot of them. And then the range, notice the range just goes from 0 to infinity, inclusive, so we get the bracket. And again, we will talk about the difference between the bracket and the parentheses if you don't remember that. We'll kind of do that in the next couple of days. So the next one we got, I'm going to give you two names for this one. A lot of you know the quadratic function from last year. The general term of this is actually the even function. So anything with an even power is going to look the same way. So again, the quadratic, we know that's y equals x squared. In general, it can be anything with an even power. So if you see x to the fourth, x to the sixth, x to the eighth, something like that, they're all going to look generally the same kind of what we call end behavior, which we'll get into more also. But again, the parent function, it's going to look like this. It's that parabola that you know from last year. Domain, again, all real numbers. And the range, just like absolute value, 0 to infinity. Again, 0 inclusive with a bracket. Next one is going to be the cubic function. And again, we have a different name for this also. Cubic obviously is x to the third, but again, it can be any odd power. And they're all going to look the same as far as end behavior and things like that. So again, generally we call that y equals x to the third, but any odd power would work the same way. Okay, and then the graph of this, again, depending on, coefficients and different terms, stuff like that, but in general, the graph of this looks kind of like an elongated S, if you will. And the domain and range of both of these is, you guessed it, all real numbers. Okay. All righty, moving on. The next one we're going to talk about is, again, I'm going to give you two names. The square root is also called the radical. So the square root function. And of course, we know that that looks like y equals root x. And again, if this little index here is even, like it could be the fourth root of x, or it could be the sixth root of x, something like that. It's all the same thing. So anytime that index is even. And this looks a little bit different now. This is going to be a little bit different domain-wise than we've seen so far. My pen's starting to die out on me. It's going to start here at the origin, and it's going to kind of rise up like that. So it's got a definite, I don't like to use starting point, but that's kind of the beginning of it, as it were. And you see now the domain is not all real numbers anymore. Now it's 0 to infinity, again, inclusive with the bracket. And the range is actually the same thing. Okay. And then we're going to do one more on the bottom here, and then I got a few more blocks on the back of the page. I'm going to put another piece of paper underneath there just to see if maybe that helps my pen. Next one. So we did the square roots. Let's go and do the cube root. And again, doesn't have a second name, but that's going to be y equals the third root of x. And the same thing applies, right? So you can do anything with an odd. So if you do the fifth root or the seventh root, you won't see that. You hardly ever see those, but anything with an odd index is going to look the same way. And this looks kind of like an elongated S. So it can be kind of up like this, going through the origin, sort of like that. It does keep on going up and down forever and ever. So again, we're back to our old friend, the domain and the range are both all real numbers. Okay. All right, we got just a couple more to go, so I'm gonna turn the page over again. Feel free to go back if you didn't quite get all those. You can go back and pause the video and rewind it and kind of take a look at those. But we're gonna flip the paper over to the back and do the last couple of them here. All right, so next one on the list, we're going to talk about the rational function. You might see some books or some other teachers also call this the inverse function. That name's kind of interchangeable. And this looks like y equals 1 over x is the parent function. And this is going to be, so this is this is probably the weirdest looking graph. This has the two branches. You got a one going this way in quadrant 1, and then one going in quadrant 3. Okay, and it does have a vertical asymptote and a horizontal asymptote. So the domain and range are actually going to be the same thing. It's going to be, so the domain is all real numbers except 0. So a couple ways we can write that. I'm going to use interval notation, same way I've been doing. So negative infinity to 0, a little union sign, and 0 to infinity. And then the range is the exact same thing, because again, negative infinity to infinity, but it doesn't hit the x-axis, which would be at 0. Okay. And that's the rational function. Next two are kind of related to each other. So the first one is the exponential function. You usually see me abbreviate that just EXP, easier to write. And this looks a couple different ways. So you might see it as y equals a times b to the x. Or the other way you might see it is y equals e to the x. And that e is called the natural base or Euler's number. And the graph of this is, again, it's asymptotic, so it never hits the x-axis and kind of goes up like that. Okay, and it doesn't matter what the base is, if it's b to the x or e to the x, they're all going to have that same basic shape. And the domain's the same, all that stuff like that. So the domain, our old friend, negative infinity to infinity, all real numbers. And then the range this time, notice the range goes from 0 to infinity, but it never hits 0. So we're going to write the range with the parentheses 0 to infinity. And then the next function, the logarithmic function, is actually the inverse, kind of the opposite of the exponential. So this is logarithmic. And again, usually see me abbreviate that just with log. And again, I'm going to give you two different equations. So you might see this as y equals log base b. The b is like what we call a subscript of x. Or if you're using e, there's another way. So you can also write this as y equals ln of x. Okay, and we'll get into those differences. And you saw the differences a little bit last year in Algebra 2. And again, if you think of the inverse, kind of it's not really a reflection, kind of is. But now, instead of having a horizontal asymptote, now it's going to have a vertical asymptote along the y-axis. So it's going to look like this. And this does go up forever, going off to the right. It goes up very slow, but it does go up forever. And so again, the domain and range are going to be kind of flipped from what they were for the exponential. So now the domain is 0 to infinity, and the range is negative infinity to infinity. Okay. And then the last one, I know I got two more rows, but really only last one. And this is kind of be a bonus. I'm not going to ask you. We're not going to really talk about this function until the spring, but I want to go and throw it at you so at least you know kind of what's coming. And it's the sinusoidal function. And a lot of times you'll see that abbreviated as a sine function. And that's going to look like y equals sine, sin of x. A lot of people say sin x. I'm not a big fan of that, but anyway. And what this looks like, it's basically a wave. It's periodic, so it repeats. So it's going to kind of come up and down like this. Keep on doing that same kind of pattern. And we're going to get into a lot of these, again, in the spring, where the maximum value here is 1, and the minimum value is -1. Okay? A lot of applications on this, and we'll talk about when we get there. So the domain here, all real numbers, old friend, nothing different. But the range, really important for the parent function, it only goes from -1 to 1. And we'll talk about why that is a little bit later on. Okay, so that is your review of all of the parent functions and one bonus one. Make sure you know the name, the basic sketch of the graph, what the equation looks like, and you definitely want to know the domain and range rules. We'll talk more about the domain and range in a couple of days. In fact, tomorrow we'll start talking about the different ways to write domain and range, interval notation, inequality notation, and set builder notation, and then how to find domains, particularly algebraically, but also from a graph. Okay. Hope this kind of jogged your memory about parent functions. Until next time, stay safe.